Good day, students. This is Mr. Mfona, your math teacher. Today, we're going to be looking at using trigonometry in right triangles to find missing sides and angles. By the end of this lesson, you should be able to apply trigonometry to find the missing sides and angles of a right triangle. The vocabulary words we'll go through today is sine inverse, cosine inverse, and tangent inverse. Now let's take a look at this problem. It says find sine h, cos h, and tan h. All right. First thing we realize here is you have a right triangle, so you can easily apply trigonometry. Let's identify our sides. So the easiest side to identify is always the hypotenuse, the side that has nothing to do with the right angle. So this is your hypotenuse there. And then your angle of reference, this is your angle of reference here, h. And so this is your hypotenuse. Now, the 9 would be your adjacent side, okay? The side that combines with the hypotenuse to form the angle. So that's your adjacent side. And then, of course, your opposite side is 12. Now, sine h by definition is what? Opposite over hypotenuse. You can always use your SOHCAHTOA to help you. See, sine is opposite over hypotenuse. So, sine, that'll be opposite over hypotenuse. But what's my opposite? Opposite is 12 over the hypotenuse is 15. But we see that 3 can go into 12 and 15. So 3 goes into 12 4 times, and 3 goes into 15 5 times. Now let's look at cos h. By definition, cosine is what? From SOHCAHTOA, cosine is adjacent over hypotenuse. So cos h, that will give us adjacent over hypotenuse. What's my adjacent? My adjacent is 9 over the hypotenuse is 15. Now, but we see 3 can go, 3 goes into 9 3 times, and 3 goes into 15 5 times. Now, similarly for tan theta, by definition, tan theta is equal to what? From your SOHCAHTOA, tangent is opposite over adjacent. So tan theta will give us opposite over adjacent. My opposite is 12 and my adjacent is 9. So I have 12 over 9. But again, 3 can go. 3 goes into 12 4 times, and 3 goes into 9 3 times. So that will reduce to 4 over 3. Okay. All right, go ahead and pause the video at this point and take down your notes, and we'll take a look at the next slide. All right, here we are asked to which is equivalent to 1/2. Select all that apply. Now we'll have to evaluate these angles. In the previous slide, we saw the definition of sine, cosine, and tangent. But now, how do we actually evaluate the sine of an angle? We'll use a calculator. Now, when you pull up your calculator, you can always get a calculator from your device. All devices have calculators. So the calculator will always be in this standard mode. You will not be able to see, if you're using the calculator from your laptop or device, you'll not be able to see the trig ratios. So you go to these 3 dots, these 3 bars on the top left there, click on it, and then you see scientific. You click on scientific, and that's trigonometry. You click on trigonometry, and those are the trigonometric ratios. So let's go ahead and look for sine 30 degrees. So first you type 30. Don't bother about the degree. So you just type 30 and then you go and click trigonometry and then you click sine. So you see that sine 30 is 0.5. 0.5 is the same as 1/2. So that is one of our answers. So A works. Now let's test all the others and see. The next is sine 45. So we type 45, click on trigonometry, and then you click on sine. See, sine 45 is 0.707, so it's not 1/2. Let's try cos 45. So again, you click on 45, type 45, click on trigonometry, and then you click on cos. It's 0.707, that's not 1/2, so that doesn't work. Let's try cos 60. So you type your 60, and then you click on trigonometry, and you click on cos. All right, cos 60 is 1/2, so that's one of our answer choices. 0.5 is the same as 1/2, so G works. Let's go ahead and test the remaining two. We have tan 30, so you type your 30, click on trigonometry, and click on tan. That's 0.577, so that's not 1/2. And lastly, tan 45, so you type 45, click on trigonometry, and click on tan. Tan 45 is 1. So the correct answer is A and D. Now let's look at the next example. We are told to find theta given the following. Round to the nearest degree if necessary. The nearest degree simply means the nearest whole number. All right, the first one says sine theta equals 0.5. So when you are given the sine of an angle, to get the angle, you take the sine inverse. So if sine theta equals 0.5, then to get theta, we'll look for sine inverse. So remember to type that, export that inverse, you click control dot, and then type -1 and click control dot again. So that will be sine inverse of 0.5. All right, so that's how you get theta if you're given the sine. And then let's work that out. How do you calculate sine inverse? You go to your calculator. Let's clear everything. Clear the calculator. Now you first type 0.5. 0.5. And then you go to trigonometry. You don't see the inverse. You click on this second function here. And now you see the inverse. You click on sine inverse. So you see that sine inverse of 0.5 is 30 degrees. So that is 30 degrees. Again, remember to type the degree, hold control, press dot, and then type 0, and then do control dot again. All right. Now, in the second example, if cos theta equals 0.5, what is theta? Again, once you know the cosine, to get the angle, just look for the inverse. So cos theta will be the same as cos inverse. So you press control dot, type your -1, press control dot again. Cos inverse of 0.5, which will be equal to, we used a calculator to work that out. So clear that. First type 0.5, and then you go to trigonometry, type second, and click on cos inverse. That's 60 degrees. So have 60 degrees. All right, next we have tan theta equals 0.5. Therefore, theta would be tan inverse of 0.5. And now let's work that out. So we have 0.5, click on trigonometry, click on second, and then tan inverse. So we have 26.565, right? Now we are asked to round to the nearest degree or the nearest whole number. Your whole number there is 26. So what you do is you check the next digit. If it is 5 and above, you add 1. If it is 4 and below, you leave it the way it is. Our next digit is 5, so we're going to add 1, and so our answer will be 27 degrees. So I have 27 degrees. We look at sine theta equals 4/5. So theta will be what? Sine inverse of 4/5. Now let's work that out. First thing again, you want to first work out 4/5 is just 4 divided by 5. So you have 4 divided by 5 equals, now we look for sine inverse of that. Trigonometry, second function, sine inverse. That is 53.1. Again, since we have the 1 there, we just leave our answer as 53. So that'll be 53 degrees. Next, we have cos theta equals 3 feet. Then theta will be what? Cos inverse of 3 feet. 3 divided by 5. Oh, I did not reduce. That's so we have cos inverse. Cos inverse of 3/5. Which would be equal to, so again, we go to a calculator, and then we first type 3/5. So 3 divided by 5 equals, and then we look for cos inverse of that. Second function, cos inverse. That is 53.1. So to the nearest whole number will just be 53 degrees. So we have 53 degrees. And lastly, if tan theta equals 7/3, then theta will be what? Tan inverse of 7/3, which will be equal to, so again, you go to your calculator, first thing you type 7/3, so 7 divided by 3 equals, and then you look for tan inverse of that. Trigonometry, second function, tan inverse. That is 66.8. So to the nearest whole number would be 67. So that is 67 degrees. All right, so that's how you find the angle if you are given the trig ratio. So again, just remember that if you know that sine theta equals 0.5, to get theta, you look for sine inverse, okay? Okay, go ahead and pause the video at this point and take down your notes, and we'll look at the next example. So we are told find the measure of angle J round to the nearest tenth of a degree. Now, the first thing we realize here is you're dealing with a right angle because you have that little square there. This is our angle of reference. What information has been given us? What is this 9.4? You see, this would be your hypotenuse. So this is your hypotenuse. So the 9.4 is the adjacent side, and then the 15.1 is the opposite side. So you know the opposite side and the adjacent side. So what you ask yourself is, which trig ratio relates the opposite and adjacent? What trig ratio relates opposite and adjacent? Well, if you look at your SOHCAHTOA to guide you, you see that it is tangent, because tangent is what? Opposite over adjacent. So we're going to use tangent to set up our equation. So from here, remember our angle of reference is J. So we'll have the tangent of J is equal to, we know by definition, tangent is opposite over adjacent. So again, remember to type fractions, you do underline. So we're going to do Control U to underline. Control U would activate underline. You see, underline is activated there. You skip 2 spaces. I always like to skip 2 spaces before I type. That will just help to lengthen the fraction bar. So tan J is what? Opposite. Now you remove deactivate the underline, right? So you press Control U again, and then you press the space bar. Every time you deactivate underline, you have to press the space bar so that the deactivation will be permanent. So tangent over adjacent, that's opposite over adjacent, right? So that will give us tan J is equal to, again, but what is our opposite? Opposite is 15.1, adjacent is 9.4. So you do your fraction again, you do Control U, keep two spaces, and then you type your numerator, 15.1. Now deactivate underline, so you do Control U again, and then skip a space. Right? That's how you type fractions. So over 9.4. So I have 9.4. Now, if you look, this is very similar to this exercise that we did here. Remember, we said if tan theta equals 7 over 3, how do you get theta? Tan inverse of 7 over 3. So similarly, if tan theta equals 15.1 over 9.4, then tan J. So it will mean that the measure of angle J would be tan inverse of 15.1 over 9.4. So I have tan inverse of 15.1 divided by 9.4. All right, so we'll use a calculator to work that out. So again, the first thing you do is you type 15.1 divided by 9.4. So you have 15.1 divided by 9.4. That will be equal to, all right, we now take tan inverse of that. So click on trigonometry, second, and then tan inverse. That gives us 58.097. But remember, we are rounding our answer to the nearest tenth. The 10th position is 0. Check the next digit. If it is 5 and above, you add 1. If it is 4 and below, you leave it the way it is. So the next digit is 9. So we're going to add 1 and we'll have 58.1. So the measure of angle J, should be 58.1 degrees, 0.1 degrees. All right, so let's look at the second example. The next example says find theta given the following. Round to the nearest hundredth of a degree. Okay, so again, the first thing we notice here is you're dealing with a right angle, so you can easily apply trigonometry. Now, what is this 17? That's your hypotenuse. Okay, this is your angle of reference there. So your hypotenuse is 17. And what else do what is this 15? 15 is the adjacent side. So we know the adjacent side and the hypotenuse. The adjacent side and the hypotenuse. So you ask yourself, what trig ratio links the adjacent side and the hypotenuse? If we go back to our SOHCAHTOA, adjacent and hypotenuse, that will be cosine, okay? So we'll use cosine to set up our equation. Now we'll have cos theta. So cos theta, you can copy this theta up here, highlight, Control C to copy, and then you paste it down there, Control V to paste. So cos theta equals, by definition, that will be adjacent over hypotenuse. So have adjacent over hypotenuse. But what's the adjacent? So have cos theta equals, my adjacent is 15, and then the hypotenuse is 17. And now to get theta, we look for cos inverse of 15/17. So theta would be cos inverse of 15/17. We use the calculator to evaluate that. First, let's type 15/17. So I have 15 divided by 17 equals. Now we take cos inverse of that. So you click on trigonometry, second function, cos inverse, and that is 28.0724. We are to round to the nearest 100. The 100 position, you have 7 there. The next digit is a 2, so we leave it as 28.07. And so theta would be 28.07 degrees. All right, go ahead and pause this video at this point and take down the notes, and we'll look at the last set of examples. All right, here we are asked to find x, round to the nearest tenth. Again, what do we notice? From the information given, this is a right triangle, so we can easily apply trigonometry. What is x? This is your hypotenuse. Your hypotenuse there is x, and then this 11 is your adjacent side. So that's your angle of reference there, 37 degrees. Now, so you ask yourself, what trig ratio links the adjacent side and the hypotenuse? So when you look at that, the adjacent side and the hypotenuse, that clearly is cosine. So we'll use cosine to set up our equation. So we'll have cos 37, that's our angle of reference, cos 37. We know by definition, cosine is equal to what? Adjacent over hypotenuse. So you have adjacent over hypotenuse. But what is the adjacent? The adjacent is 11, the hypotenuse is x. So have cos 37 is equal to, my adjacent again is 11 over my hypotenuse is x. Okay, we'll go ahead and solve that. That's a proportion, so you cross multiply by this x. So you cross multiply, you have x cos 37 is equal to 11. Now to get x by itself, we divide both sides by cos 37. So x would be equal to 11 divided by cos 37. Okay, so we'll go ahead and use the calculator to evaluate that. All right, we'll pull up our calculator and we work out this. We have 11 divided by, to do cos 37, you need to first type 37, and then you click trigonometry, and then you take cos. Now be careful, you see up here, it says 11 divided by cos 37. What you see on the screen here is the value of cos 37. So you have to press equal to. Now you get your correct answer. See that equal to there. All right, so we have 13.77, but to round to the nearest tenth. The 10th position is this 7. Check the next digit. It's 7, so we're going to round up. We add 1, so it's 13.8. So have x equals 13.8. Now let's look at the second, the next example. We have find x round to the nearest tenth. Again, we look at, that's our angle of reference there. This, of course, is your hypotenuse. Now, on this side, x here is the opposite side, and this side is the adjacent side. The 5 is the adjacent side. So you go ahead and ask yourself, what trig ratio links the opposite side and the adjacent side? Clearly you see from SOHCAHTOA, that is tangent. Tangent is what links opposite and adjacent. So we'll go ahead and use tangent to set up our equation. So we'll have tan, our reference angle there is 50.1, is equal to, tangent by definition is opposite over adjacent. So I have opposite over adjacent. So giving us tan 50.1 is equal to, our opposite again is x over the adjacent is 5. So we'll cross multiply by that 5. So have 5 tan 50.1 is equal to x. Now x is already by itself, so we just work out 5 tan 50.1. Let's use a calculator for that. So again, you clear your calculator. Always make sure your calculator is clear. And then we have 5 times, you first type 50.1, then you take the tan. 50.1 trigonometry tangent. This is the tangent, right? So to get 5 times this, you press equal. Remember to press your equal. And that gives us 5.979, right? So if we want to round our answer to the nearest tenth, we'll have to, the 9 is the what is in the 10th position. So when you round up, you add 1 to 9, it will become 10, and so that will be 6.0. So I have x or 6.0 equals x. We can flip that around and have x equals 6.0. Now for the third one, we have find x round to the nearest tenth. Again, our angle of reference is 37. This 10.3 here, that's your hypotenuse, and then the x here is your opposite side. So you ask yourself, what trig ratio links the opposite and the hypotenuse? When you take a look at that, you see that is sine, right, from SOHCAHTOA. So we use sine to set up our equation. So that will give us, our angle of reference is 37. So you have sine 37 equals, we know by definition, sine is what? Opposite over hypotenuse. Now, but what's our opposite? Our opposite is x. So you have sine 37 equals x over, our hypotenuse is 10.3. So we have 10.3. Now we'll go ahead and cross multiply by 10.3 to have 10.3 sine 37 equals x. All right, x is already by itself, so all we do is evaluate 10.3 sine 37. So we use a calculator to do that. Clear the calculator. We have 10.3 times sine 37. But first, you type your 37, then go to trigonometry, click on that, and take sine, and then remember to press your equal. Because if you don't see that equal here, this is 0.6 is not the final answer. This is just the result for sine 37. You now press equal to get your final answer. So you have 6.198 to the nearest tenth. The 1 is in the 10th position, so the next digit is a 9, so we'll add 1, so that will be 6.2. So we'll have 6.2 equals x. Or if we flip that around, we'll have x equals 6.2. All right, go ahead and pause this video at this point and take down your notes, and we'll end there for today.